It is a heavy, silvery gray metal that looks almost ordinary. But inside its atoms lies a power so vast, it can light an entire city, or erase it from the map in a heartbeat. It is 19 times denser than water. It is the heaviest naturally occurring element on our planet. And for a century, it was used for nothing more than making green glass look pretty. How did we turn a forgotten mineral into the most controversial fuel in human history? How does a single fingertip-sized pellet hold the energy of a ton of coal? And why is the world still terrified of the element with the atomic number 92? Today, we're exploring why uranium is the most powerful element on Earth. Our journey begins in 1789. A German chemist named Martin Heinrich Klaproth was experimenting with a dark, heavy mineral called pitchblende. Klaproth managed to isolate a new element. Since the planet Uranus had just been discovered 8 years prior, he followed the trend of the era and named his find uranium. For the next 100 years, uranium was an industrial footnote. It was used as a pigment in ceramics and glass to create a unique yellow-green glow. Nobody knew that the glow was a warning sign of a power that would eventually redefine the 20th century. The true nature of uranium stayed hidden until 1896, when French physicist Henri Becquerel left some uranium salts in a drawer next to a photographic plate. Even though the plate was wrapped in dark paper, it became fogged by invisible rays coming from the uranium. This accidental discovery of radioactivity changed physics forever. This led to the legendary work of Marie and Pierre Curie, who realized that uranium wasn't just a metal. It was a source of constant, mysterious energy pouring out of the very nucleus of its atoms. To understand why uranium is so powerful, we have to look at its twin versions, or isotopes. 99.3% of the uranium in the world is uranium-238. It's stable and mostly harmless. But hidden inside is a tiny 0.7% fraction called uranium-235. This is the magic isotope. U-235 is fissile. This means if you hit it with a single neutron, the nucleus doesn't just absorb it, it shatters. This is nuclear fission. When it splits, it releases heat and more neutrons, which hit other U-235 atoms. This creates a chain reaction. In a millisecond, trillions of atoms split, releasing a staggering amount of energy. Uranium isn't just dug up as a metal. It has to be manufactured. It starts in mines in places like Kazakhstan, Canada, and Australia. The ore is crushed and treated with chemicals to create a concentrated powder called yellowcake. But yellowcake isn't ready for a reactor yet. It has too much U-238 and not enough U-235. This is where enrichment comes in, one of the most difficult engineering feats on Earth. Using massive centrifuges spinning at the speed of sound, scientists separate the isotopes to increase the percentage of U-235. For a nuclear power plant, you only need about 3 to 5% U-235. But for a weapon, you need over 90%. This enrichment gap is the center of global politics and the why behind international nuclear inspections. To understand the sheer supermaterial status of uranium, look at the math. A single pellet of uranium, smaller than your fingertip, contains as much energy as 17,000 cubic feet of natural gas, 149 gallons of oil, or 1 ton of coal. In a nuclear reactor, these pellets are stacked in fuel rods. The heat from the fission boils water to create steam, which spins a turbine. It is the most efficient way we have ever discovered to create electricity without burning carbon. But this power comes with a heavy price. The waste left behind by these fuel rods remains radioactive for thousands of years. and we cannot ignore its darkest chapter, the Manhattan Project. In 1945, the little boy bomb dropped on Hiroshima used highly enriched uranium to change the world forever, turning a scientific discovery into a symbol of ultimate destruction. Even the leftovers, known as depleted uranium, are used in warfare. Because uranium is so incredibly dense, denser than lead, it is used in armor-piercing shells that can cut through a tank's steel hull like a hot knife through butter. Natural uranium is only weakly radioactive. You could hold a piece with gloves and be fine. The danger comes from inhaling the dust or long-term exposure to its decay products, like radon gas. As we look for a future without fossil fuels, uranium is at the heart of the debate. It is a Promethean gift. It provides fire without smoke. But if we lose control of it, the consequences are permanent. Uranium is more than just element 92. It is a test of human responsibility. It is a metal that fueled our brightest hopes for the stars and our darkest fears of the end. Don't forget